Hello my friends, welcome to Ender LD-002H channel. This is Uncle Misha. Today we have continuation of the saga on repairing, does it say here? Creality where the hell is the name? LD-002H MSLA 3D printer. So what do we have here? We have power supply. Why do I actually showing this to you? Okay, so let's just power the power supply. We're gonna power it up like this. Okay, so our multimeter DC. It's a bit sketchy here, so be careful, or I have to be careful and everyone else. Yeah. Let's do like this. That'll be easier. So multimeter. Okay. Here's our negative. There's our, what do we have? 12 volt. Very good. What do we have? 30 volt. Oh, looking good, but it says here 12 to 27, and channel 2 is supposed to be 24 volt dash 27 volt, 1 amp, 1.4 amp. So this is like a double power supply which has two voltages. 12 volt runs the main board and everything else, and 24 volt which runs 24-27, which I do not understand what this stands for. And it's 1 amp, 1.4 amp. Again, it's sort of confusing. Which runs LEDs. So what I cannot understand, because I don't have a schematic, if this the second channel is constant current power supply, because you cannot just freaking connect LEDs to the power supply and just pops your uncle straight up. It's gonna, you know, cause essentially LED is gonna consume as much as possible energy, and then it's just gonna burn out. So current gonna just go up, and then LED is out, unless this is either constant current power supply or it has overcurrent limit, but overcurrent in such a way that it just not exceed whatever 1 amp, 1.4 amp. So this is something I need to understand here, because this is definitely, because on the LEDs I do not see ultraviolet LEDs, I do not see any regulation, just straight up LEDs. So this is super weird power supply, but potentially it has current regulation right here. There is also here potentiometer. This thing does nothing. I cannot understand. Maybe this thing is actually a current limit. Unfortunately, I do not have beefy enough a electronic load to actually connect it here, and just to give a bit better understanding if this thing has actually current limit, and adjust it right here. Yeah, so that's what I do not have. I have this load, but I don't think it's capable of 30 volt. Okay, so what we're gonna do now, we're gonna take a look at this power supply to see maybe we can tweak something and bring it back to 24-27, because even when this thing was connected to LEDs and LEDs were shining, it was outputting 29.5 or 29 something volts. So that's, I think, some people say that this is a little bit too much for LEDs and a little bit too much for the LCD screen. That's why LCD screen is go kaput, because the UV LED outputs too much energy, and eventually the amount of energy from UV actually damages the LCD. This is the theory. Potentially it's possible because UV is harmful. So let's make sure the big ass capacitor in SMPS is discharged, and we will take it open. Okay, so as a part of exercise, before I actually start poking around with the power supply, I decided to connect LEDs to current limited power supply. Okay, so I put 24 volt and 500 milliamp current limit. Let's see what's gonna happen. Really? I cannot understand. They consume only like 30 milliamps. Sorry, I do not understand. Let's do 27 volt. Okay, 300 milliamps. So clearly they need higher voltage. But that's pretty much it. It's 300 milliamps. I'm not understanding that. 27 volt, 300 milliamps. Yeah, this power supply either has to be current limited, or it has, or these LED modules are smarter than I think they are. Yeah. Okay, this is something to figure out. Okay, the power supply. So it has to have only one screw here because I couldn't see anything else. But look, yeah, I don't know. I know how to open these sort of power supplies. I think they are pretty easy to open. Alright, something like that. Okay, so what do we have? Oh, interesting. Looks like we have two power supplies pretty much in one. We have, so this is our mains input. That's actually good the amount of, there is a MOV, some PTC, this is a fuse. We have a common mode choke. This capacitor is missing, like this, like interference capacitor. So yeah, -1 interference capacitor. Yeah, and then the actually regular paraphernalia with the switch mode power supply. But we have two transformers. So that's what I mean, two power supply in one. So they are fed by common a bridge rectifier, common small capacitor, but then we have two separate power supply, the transformers. Transformers looks to be okay, because in general the actual quality of manufacturing of this guy is more or less okay. The insulation I see like right here is actually pretty decent on secondaries, because this is one secondary, this is second secondary. The reason I'm saying, because there is one diode right here, so I assume this is 12 volt thing, and another diode is right here, I think this is 27, 24 volt thing. Yeah, 16 volt capacitor, 35 volt capacitor, 16 volt capacitor, 25 volt capacitor, 35 volt capacitor, 50 volt capacitor. I'm curious what is this the potentiometer is doing. There's a little capacitor right here, and two inductors on output. Yeah, so wow. Another interesting thing, two transistors right here. I assume those are two switching transistors. I'm curious to see if it's going to be two separate driving chips, and also there are two separate optocouplers right here for feedback. All right, two of them right here and right here. So yeah, it looks like it's absolutely obvious that we have two separate power supplies. So let's just take it open, because I think we have to dig a little bit further to see if we can actually make this thing run at 24 volts or 27 like it's supposed to be. Yeah, whatever. QC my ass. So we have to obviously then okay, that's just, no, I think I would have to kind of completely. Would I? Do I have to? Is this one here? Probably have to, because completely unscrew them. I didn't want to, but because there is no other way to remove all this. Wow, that pain there is very annoying. Where is my beefy screwdriver? Okay, transistors are free. How about this guy? Right, so now what else? I see no more screws. Just stuck. Yeah, it's pretty good. That's insulation. It's actually not too bad. And shebang. You have one driving chip actually. So well, how does feedback then works? I don't understand. You have one driving chip. Current sense resistor probably. Let me think about it at the moment, for the second. Whew, it took me some time. Okay guys, I think I figured out how to fix the voltage on this power supply in order to make it what it's supposed to be. Alright, so I did a lot of poking around in reverse engineering, and that's what I kind of derived here. So we have constant current power supply, which is based on this op-amp right here. This is the kind of just schematic of this particular part, which is responsible for 27 volts. And there is an optocoupler right here. So this optocoupler is connected to this op-amp, and it just regulates also current and voltage. So it's obviously all connected. All right, so we have two part of op-amp engaged. Essentially, one is connected to voltage reference, which is TL431, like this guy. Another one is connected to the positive rail of power supply. Okay, so the output. There is also, which I omitted here, is the current sense resistor, which actually goes between this rail and the actually positive feed to the device under load. So by the way, SD4873A, this is the driver, this little guy right here. So this we have obviously two of them. Okay, so one driver responsible for 12 volt regulation, another driver is responsible for 24 volt or 24, 27, in this case 29 volt regulation. So what I have done here, so this 5K resistor is the current limit resistor. Obviously that's like a divider between two, and essentially a comparator. They work, I think, in my honest opinion, how I understand the schematic. Alright, so over here, this is what I've added, because I find very similar schematic which actually does current and voltage regulation. So if I add it over here, so I didn't add that. So this particular guy is shish, I forgot. Oh, this is 680 kilo ohm resistor. That's what it needs. So in order to have this actually change the voltage, I could have probably tried to add another idea was to add here a divider. Okay, so change the referent voltage, which is one of the and another one is change a shift voltage right here. So by adding the 680 kilo ohm resistor right here, so this was experiment. So I actually attached the potentiometer right here and was tweaking it to the point I found the right voltage, and then I replaced it with a constant resistor, which is this guy, 680 kilo ohm resistor. So it shifts the voltage, and all this stuff starts regulating and providing 27 whatever 0.3 kilo ohm voltage. So this is what I've sort of tweaked in order to provide 27 volts. So now we have to, after I tweaked it to 27 volt, now we have to change this current limiting resistor to 1.4 amp, because our panel supposed to produce or supposed to consume, let's say the energy it needs is 40 watts. So at 27 volt, 40 watts is 1.4 amp. Obviously, because there is no schematic of any kind of Chinesium power supplies, so I had to kind of figure out this on my own, and that's pretty much what I have. If someone thinks this is wrong, please correct me. Again, I'm not big kind of expert in switch mode power supply, but so far that's does what I needed to do. Obviously, we need to also check the constant current mode, like actually load it with the constant current, load it with something and see what kind of current it operates at, and then tweak this current resistor with the proper load in order to obtain 1.4 amp constant current regulation. Yes, so let's proceed to put everything all together and use one of the magic devices I obtained recently in order to set it up to the proper current. Okay, so now we are continue. So there was a long pause for the video in order to fix this power supply, because I had to I acquired recently the tool in order to measure proper load at 27 volt 1.4 amp. This is what I'm gonna measure using this device. But when you're going to be doing that, I better to put this thing back and attach them to heatsink, because I think at this kind of load it's gonna be heating up. So I decided to not just use it freely, but attach it to the heatsink. So for that I have to reapply thermal compound. In some places it was not even applied, for example between these thingies and the case, so I have to reapply it. So I'm going to reapply thermal compound here and here, put it back on, and we're gonna do constant current configuration of this power supply. Okay, we have our power supply connected, so let's just power it up, measure the output voltage, 27 volt, 12 volt, that's alright. Now let's connect it to the load, and load says 27. Yeah, it's really hard to show you. I wish I could. Maybe I can do this. Maybe we can see something at least. Okay, it says 2733, which is alright. Now we go and pick the channel 2, set the current 1.4 amp. It's like I picked the channel 2, whatever it can be. So why I set 1.4 amp? Because at 27 volt, so at 40 watts divided by 27 in our case 0.3 equal, it's 1.46. so I put it to 1, let's do 46. So that, and as far as I know, this is the 40 watts is the power of that LED module. At least that's what it says at Creality website for this particular 3D printer. So we have to set the current in such a way that it's going to be outputting about 40 watts, providing 40 watts of energy to the LEDs. All right, we have it set. Let's do on. Okay, it went into protection. Back to 40. Okay, so it couldn't handle it at all. So let's try to change the current and see how that's gonna fly. Or let's do differently. Let's do and set much smaller current. Maybe my modification actually is bogus. Yeah. How can I? Oh, okay, that's better. That's faster. Let's do 140 milliamps. Let's see how that's gonna fly. Okay. Yeah, it can do that. Okay, let's do enter. Let's just keep increasing the current. 200 milliamp. $300 million. Okay, that's too slow. Let's do by hundreds. Okay, 400 milliamp. It can do it. 500 milliamp. Still can do it. 600 milliamp. Going fine. 700. 2707 could be dropping value. Well, I mean that's obviously the current in the drop in these wires, which are not hot. Okay, so we are 900 milliamps, and now it's gonna hit 1 amp. Still doing strong. 1.1 amp. 1.2 amp. Okay. 1.3 amp. That's weird. It's at 27, yeah, 26 volt by now. And 1.4 amp. Goes into protection. Okay. Okay. Let's see what's gonna happen. We're gonna start turning this guy. Still going to protection. Now I start trying to restart. Okay. Maybe this is not current. No, still goes into protection. Trying to restart. Yep. Okay, look, I don't understand. Unfortunately, I don't have schematic of this. What? Oh. Okay, maybe I was wrong. Maybe this is something else, this potentiometer. It actually adjusts the voltage. Okay. Not current. Now voltage is like 14 volts. I see. So yeah. Okay. So this device can't even handle more than 1.4 amp. Yeah. So it's cranked up actually to the maximum at this moment. I'm just curious. .3 is okay. Let's see how 1.31, 1.33, 1.34, 1.35, 3.6, 3.7, 3.8, 3.9. Okay. 1.39. This thing is dying. Oh, okay. Now X actually doing fine at 3.9. My hands are shaking. Mm-hmm, 1.4 is actually okay. It's doing well at 1.4. 1.4. 1.41. 26.8 volt. Yeah, it's 27. 1.41. 1.42. For 3. Hey. For 4. Okay, for 3 is fine. Alright. Alright, so we adjusted this thing to be at constant current at roughly 27 volt, 1.4 amp. So, next step is to connect LED module right here. Let's just shut it all down and see how LED, what would be the current running through LED panel. Alright, so just double check. So here my contraption has a multimeter in the amp mode, connected just like this. So this is positive, goes to multimeter out of here. So this is not negative, sorry. So this is not negative, this is positive side of it, connecting to the positive side of the LED module, negative connected straight to negative of the power supply. So this is negative, goes to negative. Obviously going to be a lot of losses in these wires, but I want to just at least understand the ballpark of the current which actually goes to the LED panel. Okay, let's just power it up and see what's going to happen. And we have only 380 milliamps, which is weird. I'm not sure if it is strong. I don't know, it's not really strong, is it? Huh. Okay, here is the second multimeter measuring voltage. 27, 26. Okay, so here is 27 volt, 500 milliamp current limit on the power supply. Let me connect this here. Let me connect this here and see. Alright, that's judging by the power supply, it's at 300 milliamp. Okay, let me increase the voltage to 28 volt. Okay, 28, yeah, need to increase the current limit because it would set. Okay, let me increase it to 29 volt. Yeah, I think this is what it runs at, unless it's busted. If it's at 29 volt. Yeah, it's about right. It's at 27 volt. It's actually right now bumped up to 385 milliamps, and doesn't go too much. It doesn't. So I'm not sure how come it's supposed to be 1.4 amps unless this LED panel is short. Yeah, sorry, not LED. Yeah, LED array. So, well, it is what it is. I'm kind of hiding it because obviously I don't want to have a lot of UV lights going around. So yeah, that's pretty much correct. So it totally runs according to the power supply. I don't know what to do. So what I can do is actually try to see if this is enough to cure a little drop of resin on a piece of plastic, something to this extent, and see if this is like makes sense. You know, like for example, measured like 1 second, 2 seconds, like for like make it, you know, few drops, and to understand if it's going to be cured in a particular amount of time. I don't know what else I can do. Yeah, because I'm not sure if this is enough. So guys, what do you think? At this moment, obviously we have repaired the power supply and tweaked its output to 27 volt, and current limited to, on this particular case, to 1.4 amp, which is probably not even needed. And but I do not understand. I never used the printer, so I do not understand if this amount of light, I close my eyes, is bright enough. I'm opening my eyes, and or not. So maybe you can tell me, because for me it looks. I have no idea. I never used this kind of printers before. So yeah, I guess I will do some experiments. But for now, this video gonna be pretty much done. I'm just curious. Yeah, panel like this is barely warm here. So because if this LED panel is short, that's pretty much it. This 3D printer is only good for parts, because the new one like this cost, if I'm not mistaken, about like 50 Canadian bucks plus shipping plus all this stuff. Doesn't make sense. I can buy a used one like this I saw on Facebook Marketplace for $80 or even $90, which is completely operational. Yeah, with some extra spare parts. It's just like, so yeah, doesn't make sense to buy the part. Yeah, so that's gonna be it for this video. Power supply is working. At any given time I can remove that resistor and it's gonna back to be 27 volt. The only thing I don't know, have to re-tweak the current, I guess. So right, I can just shut this down because it started making noises. Yeah, so I'm gonna assemble it. Oh no, I'm not gonna assemble it. I'm gonna be using it with this power supply and take a little piece of plastic and drip a few drops of resin and just to understand if it's going to be cured, for example, in like 2, 4, 6, 8 seconds or something like that. Yeah, that's going to do, but that's going to be doing off camera. And then if it's all succeeds and works, I'm gonna assemble it together and we're gonna try some prints. So thank you guys for watching. Sorry for kind of long and winding video, but that's like how you proceed with troubleshooting things which you do not understand how they're supposed to work, which is not documented, which there is no schematic. You have to do tests and probes. You have to learn a lot about stuff. So yeah, I hope that's going to be useful to someone who want to repair this power supply or this kind of 3D printer. Yeah, so, well, thank you for watching. If you have any comments, any suggestions and ideas, please comment. I'll be happy to hear from you. Stay safe, stay tuned for new videos, and take care.